Welcome back, everybody. This is video 3 of the Business Calculus video lectures, and today we're going to be dealing with another algebra review. This is going to be slightly more in-depth than the previous ones, but again, I hope it's going to be slightly shorter because this is stuff that should be reviewed. Today we're going to be talking about the distance formula, the equation of a line, and how to perform linear regression. Let's get started. So the distance formula. I'm not talking about the distance based off the amount of time you spend at a certain speed. I'm talking about the distance between any two given points, which many of you can probably remember like this. When we're talking about the distance of point 1 and point 2, where point 1 is x1, y1, and point 2 is x2, y2. So for the distance, you just look at the difference of the two x values, square it, and then add the difference of the two y values and square it, and take the square root of the entire thing. This is something that we call the Euclidean distance, named after the guy named Euclid. Real fun. So this is used to measure the distance between the 2 points. Now let's take a look at an example of it. So let's say we have the point 3, 4 and 5, -3. If you put in the equation, you get this. So now let's go ahead and use our calculator over here that you might have noticed from before. I have this set up so that you can see how to perform these computations using calculator. This one's not too bad. So 3 minus 5, enter, we get -2. Let's go ahead and square that, and we get 4. Now let's go ahead and store that for now. So hit the STO, alpha, and now we can choose any of the letters we want to store it. So usually I go with A, and enter. Now whenever I want it, I can use alpha A. I know it doesn't make much sense for this one. So let's do 4 minus -3 gives us 7. Square it, we get 49. So now let's go ahead and store this in B. So we have these two parts stored. So let's do alpha A plus alpha B. So we get 53. I know the storing wasn't too necessary for this part, but it's a good way to show you this technique to start with. Now we need the square root, so do the second button. So now we have this symbol, and you can even type in the 53 or hit second and this key down here, and it'll bring in whatever answer you just had. Enter. We get our distance is 7.28. All right. Now, for this point situation, since it was just individual points, I suggest going 3 decimal places. I know I was talking about significant digits on the previous slide, but when in doubt, go with 3 decimal places. If you just said the distance is 7, that's going to be a little bit iffy. Now, next thing we're going to talk about is the equation of a circle. This might be new for some people might not. But here is our basic equation of a circle. We have x minus h squared plus y minus k squared equals r squared. So what this gives you is the center of the circle, which is at hk, and the radius of the circle, which is the r, not the r squared. All right. Now, if we look at an example, this is the equation of a circle with center at -6, 3, and radius of 5, because 5 squared is 25. All right. Now let's take a look at some linear regression. So to do a regression, you need to be given a set of data points. And you want to have some equation which relates the data points together. When we're talking linear regression, we want a linear equation which will be of the form y equals mx plus b, where m, as many of you know, will be the slope, and b is going to be our y-intercept. If you want exponential regression, it's going to have this form here, y equals a times b raised to the x. Another form is quadratic, where we'll have y equals ax squared plus bx plus c. Now, how do you determine which of these to use? Often that's going to require you to look at the data and determine it yourself which one looks most appropriate. If you obviously see a parabola, you'll probably want to go with quadratic. Linear and exponential probably would not fit for something that looks parabolic. Now, if you only see one side of a parabola, that's probably going to be exponential, because without the other side, it's not quadratic. And linear, well, if it looks like a line, you're probably going to want to go with that. And then occasionally, depending on how you do this, you'll get the correlation coefficient of R, which tells you how close the data is to your line. So if we look at this, we can find a nice data set where the data below is the per capita GDP of Mexico since 2000. It can be used to create a regression line. The regression loon can be used to estimate the future per capita GDP for 2016. So often what these are used for is, as you can see, determining what's going to be happening in the future. Now, let's go ahead and show how all this values down here were achieved. So turn our calculator back on and go to Stat. Here we want to do the edit, where we can now edit our lists. So let's go ahead and type those in. 1, 0, 2, 4, 6, 8, 10, 12, and 14. As you might have noticed, we want L1 to always be our independent variable, often is the x. Now our next one, 9, 9, 10, 11, 11, 12, 13, 13. Now, double check things are entered incorrectly. And by that I mean entered properly, not incorrectly. We can easily see that both have the same number of points. That's good. Now we want to see how this looks like. So we can go to second, y equals, and let's go ahead and turn on our first plot. So we have that selected on. On is highlighted, so hit enter. So now that plot's going to be scattered. But when we graph this, we only see a few of them. That's because our time goes from 0 to 14, but it quickly goes above 10. So we need to change our window. The minimum x, we always want slightly to the left of our actual minimum x. So let's go -1. Maximum, we want slightly to the right. So let's go 15. Enter. Minimum, let's go ahead and start at 0. Maximum goes to 13, so let's go up to 14. Now if we graph it, all right, that looks somewhat linear. So let's go ahead and do a linear regression. So go to Stat, and now we want to calculate. So here you'll find our regressions: linear, quadratic, cubic, quartic, linear regression with different variables. LN is logistic natural regression, exponential, power, actual logistic, sine, and a few others. For this, in general, we're going to stick with the linear regular, but you will be using the other ones later. So enter. Your x variables, we put those in L1. Our y variables, we put in L2. Everything else is good. If you want to store your equation, you can go ahead and type in vars, y vars, and I'm sorry, that is incorrect. So let's go back down to that again, and we'll deal with that at a later point. So hit enter, calculate, and here is our linear regression. You can see that we already have it entered. And when you put it in, you get $14,000 per capita is the expected GDP. Now, I want you guys to go ahead and try it with this one, and I'll give you a few moments. But make sure to pause the video because I'm going to show the answers shortly. All right, hopefully you have paused it and worked out yourself. So now let's see what we get. So we want to determine if this is linear, quadratic, or more. So if you do a quadratic, you'll get this bottom one. If you do a linear, you'll get this top equation. So hopefully that helped you refresh some things. I will see you in class.